Okay, so today we're going to talk about Pascal's triangle and the binomial expansion. So let's jump right into it. So the thing on the screen is known as Pascal's triangle. Pascal was a famous mathematician. I wrote a whole paper on him this summer, so I should know some more stuff. He's from France. I think his mother got very ill, and he was a sickly child as well, but his mother got very ill and passed away, and he apprenticed with his father and had two older sisters, and Dad wanted the best for him. I think he was an accountant back then, so he came by some math genes naturally. Pascal's most famous claim to fame is this thing called the Pascal's triangle. So take a moment, go ahead and pause the video, and just look at the triangle and think about some of the patterns that you might see. Okay, so before we name any patterns, I'm going to name a couple of things or some terms in here. Each one of these things is called a row, and this is actually row 0 or the 0th row. This is row 1. Everything in Pascal starts with 0 and then 1, 2, 3. Row 2, row 3, and so on. This triangle doesn't end where it ends in this picture down here. It goes on forever and ever. The things in here are terms. So this right here is the 0th term. This would be the 0th term and the first term. And then when I get to row 2, this is row 2, the 0th term, the first term, the second term. Row 3, the 0th term, the first term, the second term, and the third term, and so on. So I'm hoping in the patterns that you saw, maybe you realize that over here, every row starts and ends with a 1. So every row starts and ends with a 1 is a good pattern. There's lots of different patterns that you can see along what we call this way, the diagonals of the triangle. But today I'm not focused on the diagonals. I'm actually focused more on the rows. And I'm going to show you why. So every row starts and ends with a 1, and in your notes you have a blank triangle on the next page. So if you want to go to your next page where the blank triangle is and fill these in, you can. I'm going to draw right here though. So if we know that every row starts and ends with a 1, so I start with a 1. The next row starts with a 1 and then it ends with a 1. The next row starts with a 1 and ends with a 1, but this term right here is found by adding the two terms above it. It's a 2. That's where this 2 right here came from. So in the next row, I start with a 1. I add 1 plus 2 and make 3. I add 2 plus 1 and make 3, and then I close out the row with a 1. And this keeps going and going and going. So let me shrink this down for a second. Let me grab this, move it over so I have some space. So if I keep going, 1, 4, 6, 4, and then end with a 1, 1, 5, 10, 10, 5, 1, and so on. This keeps going. So that is Pascal's triangle. Now, where do these numbers come from? Well, these numbers come from a thing in math that's called a combination. So before I tell you where the numbers come from, let me tell you what a combination is. In math, we have two things. One's called a permutation, and one's called a combination. And if you're in statistics or done any studying of probability, you know these two words. The big thing about permutations is that order matters. And in combinations, order doesn't matter. And the best analogy or explanation, so that you understand what I'm saying, is kind of like an ice cream cone. So I can go to the store and I can get an ice cream cone, and I'm going to get 3 flavors. So if the ice cream store has 10 flavors and I want to know how many different ways I can choose 3 of them, and I'm putting them on a cone, the order is going to matter on the cone. Because here's my ice cream cone. So I put my first scoop, and then I put my next scoop, and then I put my next one. When I eat this, I have to eat the green or the lime first before I can get to the blue. So the order matters. It matters what's on top because that's what I have to eat first. But when I have a combination and I put my ice cream in a bowl instead, it doesn't matter who you put in the bowl first, because I can spin the bowl around and eat green first or blue first or red first. It doesn't matter because I can get to every single flavor. So what we're saying is that combination order matters, permutations order matters, combinations order doesn't matter. And what we're doing is we're trying to count the number of ways that something can happen. Okay, so we're going to fill this in, and to denote combinations, they're denoted as NCR. We can also write them like this, as NR. N is your, in general, N is the total, and R is what the number of terms you're picking. So for example, if I have let me do 3. I'm going to do 2. It'll make more sense. If I have 2 terms and I want to choose none, how many ways can I do that? I can do that only one way, by picking nothing. Or if I wanted to do 2 terms, choose one of them, well, I can do that in 2 ways. Let's say I have a red marble and I have a blue marble. I can either pick 1, the red marble, or I could pick 1, the blue marble. So to choose 1, that's how you read this. You read this, to choose 1. There's 2 ways I can do that. If I wanted to do to choose 2, there's only one way I can do that because you have to pick both. So if I go over here to my empty Pascal's triangle. Pascal's triangle is a set of combinations. And what they are is instead of being NCR, they are, for Pascal, it is the row, C, the term. So for example, this is the 0th row, C, the 0th term. This is the first row, C, 0 term. First row, C, 1 term. This is the second row, C, 0. Second, first term. Second row, second term. And then third row, 0th term. Third row, first term. Third row, second term. Third row, third term. And so on. But if I go over here and I write 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. This right here is this right here. That's where I was getting these numbers from. 1, 2, 1. So these combinations are ways of counting things, and the combination numbers show up inside of Pascal's triangle. So you have an option. You can write Pascal's triangle out forever and ever. Like if I asked you to find, 15C8, you have to write out to the 15th row, and that might take a while. But instead of having to do that, let's find how we can do some math. So let me write a couple more terms. I'm going to write them in the little triangle over here. So let's do, this is 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And I'm writing this one out because I'm going to use this row right here. This is the 0th, first, second, third, fourth. This is my 5th row. And let's choose the 0, 1, 2. Let's choose the third term. So I'm going to prove to you that 5C3 is going to equal 10. And I'm going to show you how to do that. A combination formula, combination N, R, which is the same thing as this. Either way, it doesn't matter. Equals N factorial over R factorial times N minus R factorial. So if I wanted to do 5C3, I have 5 things. I want to choose 3 of them. How many ways can I do that? So according to my formula, I put 5 factorial on top over 3 factorial, and then I do 5 minus 3 factorial. So this is going to be 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 5 minus 3 is 2, so 2 times 1. 3, 2, 1 right here, and 3, 2, 1 here cancel out. So now this equals 20 over 2, which is 10. So if I have 5 things and I want to choose 3 of them, there are 10 different ways that I can do that. So let's practice doing this formula a couple of times, just a couple of times. So we have example A, 8C2. So that means I'm going to do 8 factorial over 2 factorial times 8 minus 2 factorial. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. 6 times 5 times 4 times 3 times 2 times 1. 6543, 6543. So you get 56 over 2, which is 28. So you have 8 things and you only want to choose 2 of them. There are 28 different ways that you can do that. Letter B, 10(3). That's the same thing as saying 10C3. That's going to be 10 factorial over 3 factorial, 10 minus 3 factorial. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 over 3 times 2 times 1. 7, 10 minus 3 is 7, so 7 times 6 times 5 times 4 times 3 times 2 times 1. 7, 6, 5, 4, 3, 2, 1. 7, 6, 5, 4, 3, 2, 1. So on top here we get 9 times 8 is 72 times 10 is 720. Divided by 3. 6 goes into 7 2 times. Or not 6, sorry. 3 goes into 7 2 times. 3 goes into 12 4. 240. Let's try letter C. Letter C says 7C0. Okay. Reminder, 0 factorial is always 1. So 7 factorial over 0 factorial, and then 7 minus 0 factorial. Okay, please don't write this all out. This one is just 1, so I'm going to leave it alone. But now that leaves me with 7 factorial over 1 times 7 factorial. Those cancel out. It's just 1. So this answer is just 1. Okay, and then letter D says 8, 8. That's the same thing as saying 8, choose 8. If you have 8 things and you want to know how many ways you can choose 8 of them, all 8, the answer should be 1. But let's just make sure. So on top I get 8 factorial, on bottom I get 8 factorial times 8 minus 8 factorial. 8 factorial over 8 factorial times 0 factorial. This is just 8 factorial over 8 factorial times 1, really, which those cancel out. It does just equal 1. So then you have 4 more examples. A, 7C3, B, 7C4, C is 12C1, and D is 1211, which again, reminder, this is 12C11. Go ahead and pause the video, and I'm just going to put the answers in the video. See if you can get the answers right. So these are the numbers that you should have gotten. So I'm now going to challenge you. Your next problem, it asks you to go ahead and expand x plus y cubed. So you're going to FOIL it out 3 times. And I have a secret that I'm not going to tell you yet, but I can expand this faster than you can. I know I can. So here we go. We're going to do it. We're going to race. On your mark, get set, go. I'm done. I am sure that you did not foil that any faster than I could have done my little trick. So this is the answer you should have gotten if you foiled. So if you want to go ahead and pause the video and foil it out to prove that that is what you get, go for it. But I'm going to show you my little trick. See, when you expand, keyword here, this is a binomial. Keyword, it's got to be a binomial. Binomial means two terms. When you expand a binomial to a power, you can use Pascal's triangle. So this up here is going to tell me the row that I'm in. So if I do 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and if you remember, everything in Pascal starts with 0. So this is the 0th row, first row, second row, third row. These are the numbers that I want. So you write down the numbers, the coefficients or the numbers from Pascal's triangle become your coefficients. So I'm going to write down 1, 3, 3, 1. The first term, the x term or whatever it is, the first term counts down from the power. So it's going to be x to the third, x squared, x to the first, x to the 0th. And the second term, in our case the y, counts up. Y to the 0th, y to the first, y to the second, y to the third. Little note. These two numbers, 0 plus 3 add to 3, 1 plus 2 add to 3, 1 plus 2 add to 3, 0 and 3 add to 3. Those powers should always add back up to make the row that you were in. And you just put plus signs in between them. And then you simplify. 1 times x cubed times y to the 0th. Well, y to the 0th is 1, so this is just an x cubed. Plus a 3x squared y. Plus 3xy squared. Plus a y cubed. Magic. I know, magic. So let's go ahead and let's try one more of these simpler ones. So I have a plus b to the 6th. It's a binomial. It has two terms. I want the 6th row. So you could do, if you want to go through and do 6, choose 0, 6, choose 1, 6, choose 2, and do the math for all of those, you by all means welcome to. I am going to go the other route. I'm going to write out Pascal's triangle 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 0th row, first row, second row, third row, fourth row, and then 5th row, 6th row. 1, ooh, sorry, that should still be in black. 1, 5, 10, 10, 5, 1. So 1, 6, 15, 20, 15, 6, 1. This is my 6th row. So 1, 6, 15, 20, 15, 6, 1. If you're going to check that you're in the right row, the number of terms is always one more than the row because we start at 0. So this would be the 0th term, first term, second term, third term, fourth term, 5th term, 6th term. The last term should be the row you're in. So I had 6 terms. I'm in the 6th row. And then I'm going to take my a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a to the 2nd, a to the 1st, a to the 0th, b to the 0th, b to the 1st, b to the 2nd, b to the 3rd, b to the 4th, b to the 5th, b to the 6th. Take a quick glance, make sure those powers add up to 6 because they need to add back up to my row. Slap your plus signs in between and just clean it up. So this is a to the 6th plus 6 a to the 5th b plus 15 a to the 4th b squared plus 20 a cubed b cubed plus 15 a squared b to the 4th plus 6a b to the 5th plus b to the 6th. Oops. There's your final answer. So let's keep going. Let's do a couple more. They're going to get a little bit trickier. So my next one, 2x plus 5y to the 3rd. Need your 3rd row, which we've written on the other page, but 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. These are the magic numbers you want. So I'm going to write them down. Leave some space this time. 1, 3, 3, 1. Now we have to be very careful. Before we just had like x plus y or a plus b. Now I actually have a whole term here, a whole term. So this is not just x to the third, it's 2x to the third, 2x squared, 2x to the first, 2x to the 0th. Then I have a 5y. 5y to the 0th. 5y to the first. 5y to the second. 5y to the third. Put your pluses. Oopsies. Put your pluses in between. Okay, I'm going to show you what I do. It's a me thing, just so you understand when you watch me do a problem around an answer key or something. I do my numbers. I leave my letters alone for a second. I just take care of my numbers. So this 1 is a 1. 2 to the third is an 8 times 5 to the 0th is 1. I'm going to go to my next thing. 3 times 2 squared is 4. 5 to the first is 5. 3 times 2 to the first is 2 times 5 squared is 25. 2 to the 0th is 1, the 1 in front. And then 5 to the third is 125. Okay, so 1 times 8 times 1 is 8. 4 times 5 is 20, times 3 is 6. 2 times 25 is 50, 50 times 3 is 150. 125 times 1 times 1 is 125. And then I drop my letters down. X cubed plus x squared y plus xy squared plus y cubed. I don't have the y to the 0th in this term or the x to the 0th in this term because anything to the 0th power is just 1. So there is my final answer. And I am willing to bet that using this quick shortcut is way faster than trying to FOIL that all the way out. So the next one, not hard, has one small little difference. A minus b to the 6th. So I have said many times, just slap the plus signs in between, slap the plus signs in between. It's true, and it's only because I always will do this. I will never leave it as a minus. I always change it into plus a negative, and I carry that negative with the next term. So as long as you always turn it to a plus, you can always slap your plus signs down in between. Now we did the 6th row on the other page. The coefficients, we just did these coefficients on, I think it was example 5. The coefficients to this were 1, 6, 15, 20, 15, 6, 1. Take care of my a to the 6th, a to the 5th, a to the 4th, a to the 3rd, no, 6, 5. Did I grab the wrong row? 2, sorry, I'm just not writing it. Says a squared, a squared, a to the 1st, a to the 0th. And then my b, my b has a negative on it, so just be careful. Negative b to the 0th, negative b, parentheses the 1st, negative b squared, negative b to the 3rd, or cubed, negative b to the 4th, I'm going to run out of room, negative b to the 5th, over here I have negative b to the 6th, and because I added the opposite, I again can always go back in and put my plus signs in here. So when I do my numbers, here I'm going to have a 1 times a 1 times a 1, anything to the 0th power is 1. Here I'm going to have 6 times a 1 times a negative 1. That b has a negative in front of it, like a negative 1. And negative 1 to the 1st is a negative 1. 15 times 1 times a positive 1. Negative 1 squared is a positive 1. 20 times 1 times negative 1. 15 times 1 times 1. 6 times 1 times negative 1. And this last one right here will be 1 times 1 times 1. So my coefficients are now going to be 1, negative 6, 15, negative 20, 15, negative 6, and 1. And then a to the 6th, oops, I don't need to be on this one, a to the 6th, a to the 5th, b to the 1st, a to the 4th, b squared, a to the 3rd, b to the 3rd, a squared, b to the 4th, a, b to the 5th. Let me erase this one really quick. It's too far over. And then this is going to be b to the 6th. And then you just put your plus signs in between. And there's your final answer. Oops, I got rid of my minus right there. There's your final answer. So go ahead and with your neighbor or by yourself, try this next problem. This problem says that it wants you to expand a minus 2b to the 4th. So this should be the answer you got when you were all done. Let's try a couple more examples. So this one says find the 6th term, a plus b 8th. Okay, so the first thing we need to do, let's think about Pascal's triangle. Pascal's triangle would go 0, 1, first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term, for this to be row 8. So now we have to count. If I want the 6th term, so here's 1, 2, 3, 4, 5. This is my 6th term. So it's not saying find a sub 6. What it's asking you really is to find the 6th term of the polynomial, the thing that we're going to expand. So when I do this, it's going to be this one right here. So now let's do that. So I'm in row 8. This thing up here tells me the row I'm in. So 8C5. And then it's going to be A to some power, 2B to a power. Now remember, it's the second term that counts up when you write it. So the first one would be the 0th power, second power, third power, or second, third, fourth, and then 5th. So because I'm here, this one should have a 5. The 2 powers need to add up to your row, so this should be to the 3rd. So 8, choose 5. Let's take this piece right here. It's going to be 8 factorial over 5 factorial. 8 minus 5 factorial. So we get 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1 times 3 times 2 times 1. 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. 336 on top over 3. So 112. A cubed. And then I have B, well, I have 5 to the 5th, and then B to the 5th. So I have 112, A cubed, 3,125 times B to the 5th. So multiply your two numbers together. 350,000. A cubed B to the 5th. Oof. That one was a little bit tricky just because we have to write out up here what term you're looking for. Last one. Page. See how the thing on the second term always matches right there? So I have A to the 6th, B to the 5th. So this one's much nicer because it tells you that this is the term you want, and it gives you 3A minus 2B to the 11th. So some key pieces right here. I need this 11 because that tells me 11C something. And then this 5 is what goes right here because, if I go back, because the second thing counts up. And then I got to do 3A and then negative 2B, Negative 2b, the b has to be to the 5th, and the a has to be to the 6th, and that checks out because 5 plus 6 is 11. So let's work this out. 11 factorial over 5 factorial times 6 factorial. Oh, that's definitely not enough for me. Move that over, sorry. Okay, these cancel out. And then on bottom, this is 20, 60, 120. So on bottom is 120. On top, 11 times 10 times 9 times 8 times 7. 55,400. Oops, sorry, not 400. 55,440. And when you divide, it's 462. So I have 462 times 3 to the 6th, a to the 6th, negative 2 to the 5th, b to the 5th. So let's work this out. It's going to be boatloads of fun. Boatloads of fun. So oops. Oh no. Oopsies. Changed the background and I can't figure out how to undo it. It's okay. We'll just leave the yellow for a second. So if I go over here, I have my 462 times 3 to the 6th is 729 times a to the 6th. B to the 5th is 32, and that's going to be a negative 32 because it's a negative, and then times b to the 5th. So then I need to multiply the 792 times the 462 times the 32, so you get negative 10, 7. This question asks you for just the coefficient. Coefficient means the leading number, so that is my leading number.